Hello there, this is Jude Socrates. Welcome to today's video where we will be doing a review of some basic integration. So let me show you what we're going to do today. We are going to look for four integrals. Okay, so two of them are definite integrals where we have limits in the integrals, which means that we're going to find numbers. What are the exact values of these two definite integrals? And we will also be doing two indefinite integrals, which are also called antiderivatives. And in this case, the answer is a function instead of a number. So to prepare for that, let us review some basic formulas for integrals. Okay, so first we have the power rule. For derivatives, we know that the derivative of x to the power n is n times x to the n minus 1. You drop the exponent, it becomes a coefficient, and then you subtract 1 from the exponent. On the other hand, this derivative formula gives us an antiderivative formula. So this time, if you want to find the antiderivative of u to the n du, we increase the exponent by 1, and we divide by that new exponent. Okay, and of course the general antiderivative has a plus c, the constant of integration. We can't divide by 0, so n cannot be negative 1. Okay, so you add 1 to the exponent and you divide by the new exponent. I use the letter u instead of the letter x because many times when we do an integral, the beginning variable is x, but we often have to do a u-substitution. So I use the symbol u instead of x for our general antiderivative formulas. Okay, so how about some trigonometry? The formulas are divided into two columns because on the left, the coefficients are positive 1 for the derivatives, but on the right, there is a negative coefficients for these functions. These are all cofunctions. They start with the letter c, so we have cosine, cotangent, and cosecant. So that's how you remember where to put the negative sign for the derivative. The derivative of all the cofunctions have a minus in front of the answer, but you still have to remember the rest of the answer, right? So the derivative of sine is cosine. The derivative of tangent is secant squared. The derivative of secant is secant tangent. Now, just like the power rule, these formulas give us corresponding antiderivative formulas. So this time, the integral of cosine is sine plus the constant of integration. So sine and cosine exchange roles. Cosine is now in the integral, and sine is the answer, the antiderivative. So similarly, antiderivative of secant squared u is tangent u, and so on. For the cofunctions, it is more natural if we want the integral of sine of u instead of negative sine of u. Why should there be a minus? So we put the minus on the other side. The integral of sine of u is negative cosine u plus c. The integral of cosecant squared u is negative cotangent u plus c, and so on. So let's do some integration. All right, so let's start with some trigonometry. We want the definite integral from 0 to pi over 6 of cosine 3x dx. Okay, so obviously it's the antiderivative for cosine u that we want, and our u-substitution should be 3x because that is what appears inside cosine. So if u is 3x, so du will be 3dx, and from here we can solve for dx. It will be 1/3 of du. Okay, so cosine 3x just becomes cosine u, dx becomes 1/3 du. We could also change the limits of the integration, because if we do that, then after we find the antiderivative, we don't have to go back to x to plug in 0 and pi over 6. Okay, so we can change the limits. When x is 0, 3x is still 0, so u is 0. And when x is pi over 6, 3 times pi over 6 is pi over 2. So u will be pi over 2. All right, so we are ready now to perform our integration. The integral that we want becomes, instead of 0 to pi over 6, 0 is still 0, but pi over 6 becomes pi over 2. Cosine 3x becomes cosine of u, and dx becomes 1/3 of du. All right, so we replace that. And of course, we can take the 1/3 out of the integral. So let me make a copy of this, and we can take the 1/3 outside. Okay, so we are now ready to apply the antiderivative formula. We will get sine of u, and we will plug in 0 and pi over 2. Okay, so I had to get my evaluation bar over here. So we want to evaluate sine of u from 0 to pi over 2. Okay, so remember that we start at the top. We have 1/3, and we will get the sine of pi over 2, and then we will subtract the sine of 0. Okay, sine of pi over 2, I hope everyone remembers that that is simply 1, and sine of 0, that's just 0. So we get 1 minus 0, so the answer is simply 1/3. Okay, so just to show you some magic, what I'm using to type in this lecture is a piece of software called Scientific Notebook. So it incorporates a mathematical engine that allows us to do some computations, an app, if you would. And off screen, I have a button here that lets me compute this definite integral. And boom, yep, the answer is 1/3. So I just wanted to show you that we're correct. I really would like to discourage you from getting dependent on online computational engines, okay? Do your work, learn how to integrate, learn your math, learn your calculus. Go ahead and check your answer afterwards, but don't use it to do your work, okay? All right, let's move on to the next problem. All right, so now we want an antiderivative of 5x plus 3 raised to the power 4. Okay, so we have a power 4 there, so that means that we need the power rule for antiderivatives. Okay, so again, the u should be what we see inside. So let u be 5x plus 3. So again, du becomes 5 dx, and we can solve for dx. We are going to get 1/5 of du. Okay, so our integral becomes integral of u to the power 4, and then the dx becomes 1/5 du. Okay, so we take that over here. And then as usual, we can take the 1/5 outside. So let's copy this. 1/5 will go outside of our integral. You get u to the 4th du. So our n is 4. 4 plus 1 is 5. We have u to the 5th power and also divide by 5. So it's just a coincidence that there's also 1/5 there. That comes from the substitution 5x plus 3. Okay, so we get 1/5, and then we have u to the 5 over 5. So I'm going to just make a copy of that. U to the 5th power divided by 5. So that becomes u to the 5th over 25. Okay, so the integration is done, but our original problem is in x. Okay, so we are not done. We need to replace u with 5x plus 3. So we will change u, and we will bring back 5x plus 3. Okay, there you go. And at the end of the problem, don't forget to put in plus c. Okay, just so it's just absolutely correct. All right, so now back to a definite integral from 0 to 4 of square root of 2x plus 1 dx. This is also an application of the power rule, because remember that a radical is a power. Okay, so power 1/2. So let's start with the substitution. So once again, u should be what is inside the radical. U will be 2x plus 1. So that just becomes u to the 1/2. Okay. So as usual, we will need du is 2 dx. So solve for dx, we will get 1/2 of du. Okay. Again, we can change the limits. So when x is 0, u will be 2 times 0 plus 1, so that's just 1. And when x is 4, u will be 8 plus 1, which will give you 9. Okay, so we are ready to substitute those in. We will get that our integral is now the integral from 1 to 9, not 0 to 4. And instead of square root of 2x plus 1, we will have square root of u. And instead of dx, we have 1/2 of du. Okay. And now we are going to, once again, take the 1/2 out. And to get ourselves in the frame of mind to do the power rule, we will change the square root to u to the 1/2. Okay? So the power rule says you take 1/2, the exponent in the integral, you add 1. Okay? 1/2 plus 1, 3/2. So that will be the power of u to the 3/2, and we will also divide by 3/2. Okay, so let's go. We are going to get 1/2, and then we will have as our antiderivative, need a fraction, u to the power 3/2 divided by 3/2. Okay, and we will evaluate this from 1 to 9. Okay, so it's no longer 0 to 4, it is now from 1 to 9. Okay, let's simplify this first. 2 will cancel with the 1/2 over here, so we just get 1/3. So let me steal this and change that to 3, and you will have u to the 3/2 from 1 to 9. So that will be 9 to the power 3/2 and minus 1 to the power 3/2. Okay, so 9 to the 3/2, let's do the square root first to avoid big numbers. Why should you do 9 cubed, right? So 9 to the 1/2 is just 3, much smaller. 3 to the 3rd power, that's 27. And of course, 1 to any power is still going to be 1. All right, so our final answer will be 27 minus 1. So we will get 27 minus 1, which of course just simplifies to, let me put it at the bottom here, that just becomes 26 over 3. So that is our final answer. Once again, it's a number, it's not a function. The value of this definite integral is 26 over 3. Are we still correct? And let's click on, yep, we got the right answer. All right, so for our final problem, we're going to find an antiderivative, and it looks complicated. We have x to the power 8 in the numerator, and in the denominator, we have a cube root, power 1/3 of x cubed plus 5. So don't get tempted into magically distributing that 1/3 into a sum. No, powers don't work that way. If this were a product, then you would be correct. But no, powers do not distribute to sums. Okay, so we need a u substitution. We have a power here. So let's be brave and try, like our strategies earlier, whatever's inside the power, that will be our u. Okay, so u will be x cubed plus 5. But this time, when we do du, okay, previously we only got constants, 2dx or 5dx, whatnot. This time, it's a little bit different. We get 3x squared dx. Okay, so dx is not just a constant, we will have 1 over 3x squared times du. Okay? And we have a problem because, what about the x to the 8th in the numerator? Okay? So instead of plugging everything in directly, we don't know yet what to do with x to the 8th. So let's just be brave. Okay? Continue being brave. And let's substitute in what we have so far. Okay? So x to the 8th, we don't know. But x cubed plus 5, that is our u to the 1/3. Okay? And our dx is 1 over 3x squared du. Okay, so that changes. But because we know some algebra, we can simplify x to the 8th over x squared. Okay, so 8 minus 2, that becomes x to the 6th. Okay, so that x squared is gone, but the 3 is still there. So let me scoot the 3 to the left, like that. Okay, so this is what we have so far. We have an x to the 6th remaining, okay? But we're in luck, okay? Because we can solve for x cubed in this equation, and x to the 6th is simply the square of x cubed. So I'm going to be the first to admit to you that this problem is a little bit rigged, that 8 is very special. Okay, so it allows us to get a 6th power, which works very well with our u. If this were a 7 or a 9, then yeah, we're kind of out of luck. Okay, so we have a way forward. So x to the 6th is x cubed squared. Okay, and we can get from our equation here, x cubed is u minus 5. So we get u minus 5 quantity squared. All right, so that is what we can plug in now into x to the 6th. So I hope it's okay with you. I will just continue over here, and our x to the 6th becomes u minus 5 raised to the power 2. Okay, so now all the x's are gone. We are only going to deal with u. Okay, so at this point, I want to remind you that you cannot find your antiderivative. You cannot apply these formulas until all of the original variables are gone into whatever it is you are transforming. Okay, so at this point, you're out of luck. Okay, you cannot apply the power rule just yet. Okay, you have to wait until everything is in terms of u. Okay, so let's summarize what we have so far. Our problem has now been transformed to 1/3 u minus 5 to the 5th power divided by u to the 1/3 du. Okay, so that is what we need to integrate. Okay, still we cannot apply the power rule directly because yeah, there's a u minus 5 there and the 2 and the 1/3. What is going on here? Okay, however, we know some algebra. Okay, so we know how to expand a square. So let's do that in the numerator. U minus 5 squared is the same as u squared minus 10u plus 25, correct? Everyone knows how to square a binomial. Okay, so we get u squared minus 10u plus 25. Okay, so we are still not yet able to apply the power rule, but we can distribute the u to the 1/3 to the 3 terms in the numerator. Okay, so that is a valid application of a distributive property that we all know. Okay, so power rule, okay, we have u to a power divided by u to another power. Okay, so when you're dividing powers of the same base, you subtract the exponents. Okay, so we have 2 minus 1/3, 6 minus 1, we get 5/3. Okay, so let me do that over here. Okay, so we are going to work from this. 2 minus 1/3 is 5/3. Okay, u to the power of 1. So 1 minus 1/3, that's going to be 2/3. U to the power 2/3. Okay, and finally 25. Oh, there's no u there, so that's u to the 0. 0 minus 1/3 is power negative 1/3. There we go. So now we can apply the additivity property of the integral, and we will treat each of these terms separately. Okay, and apply the corresponding power formula. Okay, so we will do the integration. That's gone, and the du is going to be gone. So now, for each of these, we need to apply the power rule. We're going to add 1 to the exponent and divide by that new exponent. Okay, so we're going to need fractions. Let me prepare ourselves by making 3 copies of fractions. Oh, hey, I forgot the u over there. There you are, and there you are. Okay, so that's 5/3 plus 1. So we need 5 plus 3, 8/3. Okay, so we will need u to the power 8/3 divided by 8/3. Okay. How about 2/3? Okay, 2/3 plus 1 is 5/3. So we need u to the power 5/3 divided by 5/3. 5/3. Okay, exciting. So finally, oh, where are you? There you are. U to the minus 1/3, add 1. So that's going to be positive 2/3. Okay. So we get u to the positive 2/3 divided by 2/3. Okay, cool. So plus C, if you want to put it on right now. And we have to bring back our u, so luckily we still have it here. U is x cubed plus 5. Okay, so let me put that over here. Just we're going to scroll down a little bit to give us a little bit more space. Whoops. There you go. So that's our u. And check it out. We also have a 3 here, and you have lots of 1/3 over here. So those all cancel. So we get just 8 in the denominator here. And then we will get just 5 over here. Yeah, ooh, but wait a minute. 10 over 5, that's just 2. Ooh, it keeps getting better. Okay, so that's just 2, and we can get rid of 5 over here. Okay, that's all we have there. This 3 is also gone, so we have 25 over here. Oh well, can't have everything. So the 1/3 is gone. We don't need those parentheses anymore. And for our final step, we will bring back our x cubed plus 5. Okay, so u is x cubed plus 5. Bring that in here and change the 2 other u's into x cubed plus 5. Okay, ta-da! So that's it for our video for today. I hope you found it useful. If you have a test coming up, or maybe you are trying to prepare for the next semester of calculus, I wish you the best. Thank you so much for watching my video, and I will see you very soon. I hope you enjoy the rest of your day.